Hey everyone, this is Miss Cologne here. I'm going to show you a quick video on how do you find the probability of something only with simple events. Basically one chance. So let's start the basics. Well, what is probability? Probability is basically that chance you get of a likely event to happen. So there's a chance that something is going to happen or occur, okay? So basically, one of the examples of probability is a simple event. So a simple event is just one outcome, okay? That one occurrence. So a simple event is just that one outcome or a collection of outcomes. Typically, example, if I only have one spinner, or if I only flip the coin one time. So, an outcome, because we've been seeing that word outcome, here's outcome. So, outcome is like the result, okay? But it's not just any random result, it's the possible results, okay? It's a possible result whenever we're trying to find the probability of an event, okay? Now, there are three different ways you can write out probability. Majority of the time, we see it as a fraction. Majority of the time, you can see it as a fraction now. Of course, when we're talking about chances, like a percent chance of rain, a percent chance of getting in an accident, we also use percents. So we can change a fraction to a decimal as well, which the decimal can be changed to a percent. And we've learned how to change and interchange between these three. So once you write it as a fraction, you can always change it immediately to a decimal, which then changes it to a percent. Now, like I said, probability, I mostly write it as a fraction, but we also have a fancier word for that. When we write it out as a probability, it's usually a ratio. And again, we've seen this word before. It just compares the numerator from the denominator. In this case for probability, it compares the favorable outcomes, the chances that is going to happen over the total number of possible outcomes. So I typically write it like this. The probability of whatever the event is, when I write it as a fraction, the numerator is always the favorable outcome. Okay? That's always a number. The denominator is usually the possible outcomes, or to make it easier, it's a total. So total chances. So for instance, if I wanted to flip a coin, well, a coin is only heads and tails. So your possible outcomes to flip a coin can only be two options, heads or tails. But if I say, what is the probability of flipping a heads? Well, that's only one favorable outcome, because in a coin, you only get one heads and one tails. This would have been written as 1/2. So just keep that in mind. So, looking at this number line, when we're talking about probabilities, we're also talking about the likelihood that it would occur. The chance that it will be possible, that will happen. So, when we look at it, we can also look at it as a percent, like I said, or you can look at it as a fraction. Now, if it's 0%, that means there is no chance that event is going to happen. There's no chance. So that's considered impossible, right? You get 0, it's impossible, okay? Now, 50%, like I said, that's if you flip that coin. What are the chances I'm going to flip heads? 50%, 50%. So it's in the middle, okay? It's not impossible, but it's not completely certain, because that's just a 50% chance. It can go one or two ways. And then if I'm looking at 100%, I am certain. That means you are confident, you're for sure. No, whatever the probability or chance of whatever we maybe pull out of a bag or flip a coin or spin a spinner, okay? You are certain of that chance. So let's do a quick example down here. Number 1, a cube with size labeled 1 to 6 is rolled. Find the probability of rolling a 6. That's how you read that P in parentheses 6. Read the probability of rolling a 6. We're going to write it as a fraction, decimal, and percent. So let's do the fraction first, because that's typically easier. What are the odds of rolling a 6? Well, first off, your denominator represents your total outcomes. They told me a cube is labeled 1 to 6. So that's 1, 2, 3, 4, 5, and then a 6. So the total possible outcomes that I will roll that cube is 6 options, okay? So 6 would be in the denominator. Now, what is the likelihood of rolling a 6? Well, let me list out the options that they said we have. We got labeled 1 to 6, so that's 1, 2, 3, 4, 5, and 6. The odds of rolling just a 6, if you can see here, it only will be one time because I only have 1 6. So the probability of rolling a 6 is 1 over 6. Now, that's written as a fraction. If I wanted it as a decimal, you simply just divide. 1 divided by 6. You get 0.16 repeating. And then to change any decimal to a percent, you typically multiply by 100. Or use your calculator, multiply by 100 or move the decimal 2 places to the right. This becomes 16.6 and it's repeating again, percent. So I want you to think about this carefully. 16%, if I'm looking at my number line, 16% falls between 0% and 50. What this means is the likelihood chance of me rolling that cube and landing a 6, it is unlikely because your percentage fell between 0 and 50. Now, I'm not saying it's impossible. It is possible because this is not 0%. I just want you to understand. It's just not likely that if I roll by chance, I'm going to get 6 every time I roll the cube. So this is unlikely that I'm going to roll a 6, at least the first time, or maybe the second time, or ever how many times I need to roll. So I need you to keep in mind what this means in terms of likelihood. Let's do another one. Let's look at number 3. Find the probability of rolling a 2, 3, or 4 on the number cube mentioned from number 1. So again, we're going to use the same numbers. I got 1, 2, 3, 4, 5, 6. Let me lay out my possibilities. It's still 1, 2, 3, 4, 5, 6. So now the probability of rolling either a 2, 3, or, and that or, and I'm emphasizing it too much, but there's a reason for that. Or means I have more of a chance. I have options. I'm not rolling a 2. I'm not rolling just a 3. I'm not rolling just a 4. The chances are either rolling, I get a 2 or a 3 or a 4. So we still have 6 possible outcomes. So out of the 6, the odds of rolling a 2, all right, is 1 right here. The odds of rolling a 3 is right here. And then the odds of rolling a 4 is right here. So I have 3 possible outcomes out of 6 possible outcomes. So I have 3 out of 6. Now, that's as a fraction. If I want it as a decimal, you just simply divide. 3 divided by 6. You get 0.5. But when you usually have a decimal and it's one decimal place, it's okay to just put a 0 because it makes it easier to change this decimal to a percent. And 0.50 as a percent is 50%. Now, I did notice I did put this entire question on number 2. It is meant to be for number 3. Apologies on that. So I just want you to keep in mind this question, the work is supposed to be for number 3, not for number 2. Okay, I'm gonna have you look at that for a second. You can pause the video, write down the notes. Okay, we're gonna do number, excuse me, we're gonna do number 4. So, find the probability of not rolling a 6 in number 1. So I'm still using these 6 numbers again. Here's my cube. 1, 2, 3, 4, 5, 6. Now, they're saying the probability of not rolling a 6. What that means is, out of my 6 possible outcomes, how many chances will I roll any other number and not 6? So we're only going to circle what is not 6. We can circle 1, 2, 3, 4, and 5. And what that means is the chances of rolling not a 6 is 5 over 6. And if I change that to a decimal, that becomes 0.83, repeating. And if I change that to a percent, this is going to be 83.3%. Now, going back to my number line, because this number, 83%, it is between 50 and 100. So the likelihood of me rolling that cube and getting any number other than 6 is likely because this percentage is much higher. I am most likely gonna land any of these numbers. I have more options. 6 is not gonna be included. So what are the odds that I'm gonna roll 1, 2, 3, 4, or 5? It's very likely because this percentage is higher than 50, but not at 100. If you need to pause the video, go ahead and then review these notes. This is just for probability for simple events. Thank you, guys.